Hello everyone. Okay, this video I'm just talking about keep contact talks about center of mass, and this video I just show you. Okay, we're in a system of particles. We need the concept called center of mass to reduce the to make our analyzer system much easier. Okay, the center of mass is a very special point, and yeah, most of the time you cannot see it. That's why you need to calculate it. And we show an example to calculate center of mass in discrete system and continuous systems. Okay, and more further, okay, let's look a little about the motion of center of mass. Okay, yeah, because to treat a center of mass as a very special point or special particle, and what's the motion of this particle? Okay, so we this is a definition of center of mass we previously introduced. Okay, so we want to right now we want to look at the motion of center of mass. So when discuss the motion, yeah, in the very early of this semester, we introduced the kinematics. Yeah, and what's the kinematic? What is kinematics talking about? Kinematics is talk about the relationship between what? Do you remember that? Kinematics describe the motion, the relationship between the position, velocity, and acceleration, right? Okay, and you want to get a velocity vector from position vector. What will you do? You do the derivative with respect to time. You want to obtain acceleration. Acceleration from velocity. What you do during the derivative? Okay, and kinematics is discussing the relationship between the position, velocity, and acceleration. So, in previous lecture, we give the definition of the center of position of the center of mass. Okay, so let's move a little further. Okay, let's talk about the velocity of center of mass and acceleration of center of mass to see what happened. Okay, so here is the position. Okay, but position vector of center of mass. Okay, that's okay. Okay, position of center of mass is equal to or what's this? Yeah, 1 over capital M is summation alpha m alpha r alpha. Okay, so want to calculate obtain the velocity vector of center of mass. What will we do? We do the derivative of the position vector. Okay, and then we just doing derivative with this summation alpha m alpha r alpha. Okay, and I believe you already learned a little about the calculus. Okay, so because the total mass of system is constant, and the mass of each particle is also a constant. When they do in motion, so mass is a constant, so mass can factor it out. So we only have to do doing the derivative on the position vector of each particle. So this will become like this: m summation alpha m alpha n d r alpha dt. Because mass is constant, so we only do a derivative on the position vector only. Okay, so okay, d alpha is each d r alpha dt is equal to the velocity vector of each particle. So we will reach this conclusion. Sorry. Yeah, I should write a VCOM here. Sorry, VCOM. Okay, so we'll reach this conclusion. VCOM is equal to 1 over m times summation alpha m alpha v alpha. Okay, so it's very similar to the formula to center of mass, right? Very similar, right? And we do a little bit algebra work. We'll reach this one. We times n to the times the capital M on both sides. We will have the m VCOM equal to summation alpha M alpha V alpha. Actually, this is the okay. So what this equation means? Okay, let's look at this equation. The purple, the red or purple. It's not a purple red. What's the color of this? So it's in English. Okay, never mind. Okay, the right hand side is the momentum of center of mass, momentum of the COM, momentum of center of mass. And what's the right hand side? Total momentum of the system of particles. Okay, because the right hand side summation alpha M alpha V alpha is just the momentum add the momentum of each vector together. That's because that's the summation alpha M alpha V alpha mean the summation of each the summation of momentum of each particle and summation all together. So it's a total momentum of the system of particles, and is equal to the left hand side total mass m times the velocity vector of center of mass. So this is what we mentioned before. The center of mass is a very special point. You can view it the whole system can concentrate at one point. Okay, and so the total momentum of the system is equal to the momentum of center of mass and time. Yes, the total momentum of system particle equal to the momentum of center of mass. Okay. So if we want to know the total momentum of a system of particle, you don't have to add everything of them, because that's sometimes very difficult. So you just calculate the velocity of center of mass and times the total mass. Yeah, it will give you the total momentum of system of particles. Okay, and then we do a little more further. Okay, so the next one is acceleration, right? Because position, velocity, and acceleration. Right here. Okay, so then we continue. Okay, ACOM is doing derivative of velocity vector of center of mass with respect to time. Okay, and that's what's the velocity of center of mass. Yeah, we already obtained here. Okay, so it's equal to dt and 1 over capital M summation alpha M alpha V velocity alpha. Yeah, we use the same procedure. Okay, because capital M and the mass of each particle are constant during in the system, so we factor it out. So we will obtain this. Yeah, a summation alpha M alpha dV alpha dt. Okay. So so we do the same. So and then I think I move here. So we will obtain the result. The acceleration of center of mass equal to 1 over capital M and summation alpha M alpha, and the velocity vector of each particle derivative with respect to time is acceleration of each particle. So acceleration vector of each particle. Okay, that's what our conclusion. So you say it's also a very similar formula of the velocity of center of mass. And we do an algebra work the same. I think you might understand what I'm going to talk about. Total mass m times the acceleration of the center of mass is equal to summation alpha m alpha a alpha. And we will apply Newton's second law of motion, F equal to ma. So this is summation alpha F alpha. Okay, so what this equation tells you about? Yeah, this will be very important conclusion. In previously we mentioned the net force net force. The net force of system of particle. Net force of the system of particles is equal to what? Is equal to total mass times the total mass times the is equal to yeah, we don't want to address this anymore. The net force is equal to the total mass of system times the acceleration of center of mass, and that's why we previously showed in this slide, or a sentence shown in this slide. Net force is acting on the center of mass. Okay, so this is shown in this mathematical formula. The net force of system of particle is equal to the total mass times acceleration of center of mass. Okay, so if you want to calculate the net force of system particle, yeah, the only thing you have to calculate is the total mass times the acceleration of center of mass. It gives you the net force of system particles. Also, that can reduce lots of calculation burdens. Okay, so let's just show you the very the motion of center of mass. So actually, you can see the center of mass. This is spatial particle. Okay, center of mass, center of mass is valid. Is also valid or obey Newton's law of motion. Okay, center of mass obeys obeys Newton's law of motion. Newton's law of motion. Law of motion. Okay, center of mass is a very spatial particle, but it still obeys Newton's law of motion. Okay. So center of mass, yeah, you cannot see this special point, you cannot see it, but this point obeys Newton's law of motion. Okay, you can reduce the calculation burden. And the final part of this video, I just doing a full further discussion of the center of mass. Okay. This not center of mass, the velocity of center of mass, because there will be example problem and homework problem. You need this concept to solve it. Okay, let's discuss this. Okay. And sometimes you will in some problem you encounter this situation. Okay, the center of mass, the system, your system particle, the center of mass, the velocity of center of mass is 0, and no external force, Okay, in this situation, what would happen? The center of mass velocity is 0 and no external force. Okay, because like what I just said, the center of mass obey the Newton's law of motion. Okay, so let's use a very simple kinematic equation. Okay, xf equal to xi plus vi times t plus 1/2 at squared. Okay, so if this particle velocity is 0, and no external force, that means no acceleration. So this particle doesn't move, right? So same thing here. If the velocity of center of mass is 0 and no external force in the system, so this will tell you this. So this will tell the center of mass doesn't move. Center of mass does not move. And how to describe this center of mass doesn't move by mathematics? Let me check. I kind of forgot. Okay. If the center of mass doesn't move, okay, if you want to use mathematics to describe this, that means the delta R COM is equal to 0. Okay, and let me see. Okay, so delta RCOM to 0. Okay, so let's write down the delta RCOM. Delta RCOM is very similar to the equation we just saw over to calculate center of mass is 1 over capital M and summation alpha M alpha, and here we just use delta R alpha. Okay, we just replace the small d to delta. Okay, because the center of mass doesn't move, that means delta R still is equal to 0. So this is 0. So this is 0. Okay, so we will reach an equation like this: summation alpha M alpha delta R alpha equal to 0. Okay, when your center of mass doesn't move, you will find this equation. Okay, and then you can use this equation to solve the example problem in this chapter. Yeah, I will demonstrate an example in the center. Oh, I will next video I will demonstrate the example to use this equation sigma alpha M alpha delta alpha to solve the problem. And also in your homework 9.45, okay, it's also use this equation to solve the problem. Yeah, that situation very special. The center of mass doesn't move, and your system doesn't have any external force, and that means your center of mass doesn't move. Okay, if center of mass doesn't move, you'll reach the equation like this. Okay, and I'll demonstrate some example in the next 1 or 2 videos. Okay, and so this is the motion of center of mass. Okay, so I hope you can understand the motion of center of mass. It's just like, yeah, it's just like, just treat it as a very special particle, and this special particle, yes, center of mass is a very special particle, and this special particle obey Newton's law of motion. Okay, yeah, but you cannot see it. It's very strange. You don't see it, but the thing you cannot see, but you obey Newton's second law of motion. Okay, so okay, I'll start a video here. Okay, see you in the other video. Okay, bye bye.